My name is Tatyana Goldberg. I'm a PhD student in Munich, at TU in Munich, in the lab called ROS Lab. And what the lab does, we develop all kinds of prediction methods that predict aspects of protein structure and protein function. All our methods, they run on our own, but we also have combined them into one suite called Predict Protein. This suite is accessible online. This is the web page. And remarkable is that this software is now 23 years old. It was established in 1992. Back then we had just 3 methods incorporated, and right now we have over 30. And if you think it's even younger than Google, because Google was established in 98, and it's just remarkable that this protein has survived for so long. It has not only survived, but it has also constantly grown. And we really think that one of the reasons why people found it so useful is that because, well, every prediction method, especially mathematics prediction method, the output of it is just text, right? And looking at the text is interesting, but not so much. It's much more revealing if you look at the visualization of it. And we were always trying to visualize the results. Before, we visualized them as HTML pages, but at some point we ran through Bio.js, and at the same time we luckily also decided to redesign our Predict Protein, and this is something that came out of it. Here we show just a snapshot of our visualization results. Everything is highly interactive, and if we consider all the prediction results again, so these are just results of 4 methods or so out of 30. But if you look just at them, we can see already that, for example, for this protein that we know that is localized from experiments, we know that is localized in the ER membrane, we can see in the prediction that this is indeed the case. We also know that this protein is a membrane protein, and we see in the predictions that exactly we predict some transmembrane helices. We also know from experiments that it is disordered, and as we can see here as well. Again, if a user hovers with the mouse over this strings, then there will be all possible information shown. What is the prediction method, what are the coordinates, and so on. We also know from experiments that this protein is involved in protein folding and apoptotic process, and this we predict also correctly. However, what we do not know from experiments, but what we can see from our visualization with Bio.js tools, is that if we look at the secondary structure prediction, for example, at this piece, which we know is a beta strand, and if you look at this strand here, which shows the effect of amino acid mutations, we see that they match. And we can suggest experimentalists that probably this beta strand has some functional effect, and the mutations in this region could be followed up by experiments. And that's our Predict Protein. Thank you. By the way, while we were developing this software, a whole bunch of Predict Protein components was developed along with Predict Protein. So this was a very nice collaboration with Bio.js. Other questions?
So it's not free for commercial use?
For commercial use, it is not. However, we also have an open version of Predict Protein where your results are not being saved. So you can run it for free, but you cannot retrieve the result from your previous run. So just visit the website and there will be a link.